scholars, I hope you remember what we discussed in our previous video. We revised the basics of data handling. Yes, we looked at different types of data, various terms related to it, and also different ways of representing it. Great. Now, there is something special about the group frequency distribution table. Remember? Let's have a look. Take a look at this table. We already discussed everything about it, right? But guys, one thing that went unnoticed is that the class intervals are continuous. And what do I mean by continuous? Well, the upper limit of one class is the lower limit of the next class. See, 0 to 10, 10 to 20, 20 to 30 and so on. Every class is in continuity. For example, 10 is the upper limit of the first class and also the lower limit of the next class. Such class intervals are also known as exclusive class intervals, as the upper limit of a class is not included in that class. For example, the observation 20 will not be included in the class 10 to 20. It will be included in the class 20 to 30. Just reminding in case you forgot. Now let's move forward and consider one more example. A teacher conducted a test in a class of 60 students and represented the data in a tabular form like this. Here it is clearly visible that only one student scored a full 50 because the test was out of 50 and no student can score more than 50, right? Essentially, the last interval indicates the number of students who scored 50. Similarly, no student scored less than 10 since the first interval begins at 10. This means the previous interval 0 to 9 will have 0 students. Now, this table is somewhat different from the previous one. Can you point out the difference?
Here the class intervals are starting from 10, unlike the previous one which is starting from 0.
This is true, Jack, but this is not what we are looking for. Try again.
Here the upper limit of the class is not the lower limit of the next class.
Well done, Jack. I'm impressed. This is what makes this table different from the previous one. Any idea what we call such intervals?
Discontinuous class intervals?
Yes, you said it right. Such intervals are called discontinuous class intervals. A unique thing about discontinuous class intervals is that the upper limit of a class is included in that class. For example, the class 10 to 19 includes the observation 19 as well. Similarly for the other classes. Interesting, isn't it? Now suppose there are 2 new admissions in the class. These 2 students also write the test and their scores are 19.5 and 49.5. Now we have to include their scores in the frequency distribution table along with other students. In which interval shall we include them? By what we have learned so far, we know that the class 10 to 19 includes scores 10, 19 and the in-between scores. Similarly, the class 20 to 29 includes scores 20, 29 and the in-between scores. So where shall we include 19.5? We cannot include it in the one ending with 19, not in the next one starting with 20. This means we have to change this table and its classes. So, to overcome this problem, we have to convert the discontinuous classes into continuous one. Now join me in what I am doing and consider only class intervals. There is a difference of 1 mark between any 2 consecutive classes, right? So, take 0.5 from the lower limits and add it to the upper limits. So we get these intervals which are continuous class intervals. So basically what we did is we subtracted 0.5 from the lower limit and added 0.5 to the upper limit. And by doing so, we changed the discontinuous class intervals to continuous one. This was easy, right? But you must be wondering what just happened here. Is it some kind of magic? Obviously not. So let's check the principle behind this and see how it works. Consider any two consecutive classes, say 10 to 19 and 20 to 29. Now, take the upper limit of the first class, which is 19, and the lower limit of the next class, which is 20, and find their difference. So, 20 minus 19 is 1. Now, half the difference so obtained. Here we get 1 by 2, which is 0.5. Half of the work is done, guys. Now we just have to subtract 0.5 from each of the lower limits and add 0.5 to each of the upper limits. So, subtracting 0.5 from each of the lower limits changes them to 9.5, 19.5, 29.5, 39.5 and 49.5. And adding 0.5 to each of the upper limits changes them to 19.5, 29.5, 39.5, 49.5 and 59.5. Now everything must be clear to you. So now it is possible for us to include the marks of the new students in these classes. So in which class shall we include 19.5? Yes, you said it right. 19.5 is included in the class 19.5 to 29.5. And the frequency of the class changes to 21 plus 1, which is 22. And 49.5 will be included in the class 49.5 to 59.5, thus making the frequency 2. I hope there is no confusion regarding this. Now, the total frequency changes to 62, which is the exact number as there were 2 new admissions to a class of 60 students. Great! So guys, it's time to wrap up the video. See you in the next video with more amazing concepts. Now, let's do a quick recap. In case of continuous class intervals, the upper limit of one class is the lower limit of the next class. Also, the upper limit of a class is not included in that class. In case of discontinuous class intervals, the upper limit of one class is not the lower limit of the next class. Also, the upper limit of one class is included in that class. To convert discontinuous class intervals to continuous class intervals, firstly take any two consecutive classes. Next, find the difference of the upper limit of the first class and the lower limit of the next class. Lastly, add half of this difference to each of the upper limits and subtract the same from each of the lower limits.